Hey guys, Mr. Roden here. Hope everyone's having a good weekend or had a good weekend. It is Sunday afternoon when I'm doing this, so I've had a pretty good weekend. I was able to get outdoors some and enjoy the outdoors. It was windy yesterday. Boy, I tell you what, it was windy. And then today it's just been a nice, relaxing day. So my daughter and my wife, my youngest daughter and wife, are in Kentucky because I think my daughter's going to go to the University of Kentucky. That's where she would like to run. So my wife and daughter have been sending me all these, just let me know how nice it is in Kentucky. I've never been to Kentucky, so I wonder if any of you guys have been to Kentucky. So that's my good thing for today. Wonder what your good thing is. Be interested. If you have a really, really good thing, save it and let us know tomorrow, Tuesday, when you get it. And I'd like to hear what it is. Let's look at the learning target today. I can apply definitions, postulates, and theorems to angles formed by intersecting lines. Well, that sounds like a learning target we've done, right? This is actually the same. This is the same learning target we had last Thursday. But a couple things I want to do today is, first of all, I want to review the things we learned on Thursday. So I want to just kind of go through my notes. I kept them here, and we'll just kind of look through them. And there's going to be a few things I want to kind of emphasize from that lesson. And then I want to go into a couple things that were really, really important. Okay, so let's dive into it. One thing is, I believe that homework assignment is going to be due Monday night. So if you're watching this, it will be tonight. I'm doing it on a Sunday, but we'll pretend it's Monday right now. So make sure you get that done by midnight, guys. Okay, and I am going to put that in. I'll probably put it in sometime on Wednesday morning. So make sure it's done by midnight. That's a homework assignment that's in the homework bucket. All right, so let me go through. I don't need to go through the old warm-up before. Okay, so one thing we want to talk about is vertical angles. All right, and vertical angles, we can see this picture right here. Vertical angles are always congruent. Doesn't matter. Just boom. When two lines intersect and you get vertical angles, they are always congruent. So you can see that 2 and 4 are congruent and 1 and 3 are congruent. Vertical angles are always congruent, which means they always have the same measure. They're all, if you put a protractor on angle 1, you're going to always get the same measure as angle 3. You put a protractor on angle 2, you're going to always get the same measure as angle 4. So vertical angles, regardless, are always congruent. And then we're going to use that over and over and over and over again this year. Okay? So keep that in mind with vertical angles. And then we did a proof. I won't go back through the proof because I am going to do some proofs today in this lesson, but I won't go back through all these proofs. So if you look back in your notes and you're really wanting to know what the proof looked like. But one thing I will say is, because it's a theorem, see, it's a theorem, guys. Theorems always come with a proof, a deductive proof where we can use absolute predetermined logical reasons to go from one point to another. And so that was our proof. I won't go through the whole proof again, but it is a proved statement. Once you do the proof, though, guys, the proof's over. The proof is like by itself. We have it now, but now we don't, every time we use vertical angles, we don't talk about the proof because the proof is something we've already established. And so we don't do it. We know it's there and we don't need it anymore once we proved it. All right. Vertical angles theorem. We talked about that. Vertical angles are always congruent. And then we went through and did some examples. Okay, so another thing we talked about are complementary and supplementary. Now, complementary angles are two angles whose measure sum is 90. All right, and like I said in that lesson, complementary angles are not nearly as common. So I'll just quickly mention those. But what we really are interested is supplementary angles, okay? And two angles whose sum is 180. Now, there's two kind of ways you can look at supplementary angles. You can look at them when they're separate. We could look at the non-adjacent example. We could have 150 here, we could have 30 here, and we can say, okay, so these are non-adjacent to each other, but they add up to 180. This is not as common. Where we really see it is in the adjacent example. Okay, it's when we have a straight line. Let me draw that. We have a straight line, And we know that there's 180 degrees in a straight line. That's the definition of a straight angle. Okay, so there's 180 degrees in this line right here. And we know that, oops, sorry. What happened to me there? What happened? We know that on this 180 degrees, and then there's a ray coming out of that. Well, this is called a linear pair. It's a very specific example of supplementary angles where you're talking about a line that's a pair that makes a line, okay? So linear pairs are always supplementary. So keep that in mind. A linear pair is always supplementary because they make up a straight line. A straight line is 180 degrees. If you have two angles who, by angle addition postulate, we get a straight line, then they're a linear pair. Okay, so just keep that word in mind because linear pair is a really common term that we're going to use this year. All right, we've got adjacent angles. Okay, now the next thing we learned is this whole transversal thing. And a transversal is a line that intersects two or more lines. So you can see this green line right here, and I purposely made these other two lines non-parallel lines because I didn't want you to get automatically into the parallel lines. And then we went through and we kind of looked at all the different angles that are formed. When you have two lines in one transversal, you get 8 angles. And then we went through and we kind of just started to list off all the different kinds of angles we had. Well, the first thing we had is there's lots of different things. We had the we have the same side interiors. Okay, well the same, and I think I erased some of this work because then I did new ones. Our same side interiors are 2 and 5 and 3 and 6. Those are same side interior angles. So now 2 and 5 are a pair, and 6 and 3 are a pair. You can't cross the transversal. So those are our same side interior angles. Pair 5 and 2 and pair 6 and 3. The next thing we talked about some of the exterior angles, but today I want to talk about the alternate interiors and the correspondings. So I'm not going to get into like the alternate exterior like 1 and 8 or alternate same side exterior like 1 and 7. I'm just going to talk about the interiors and the corresponding, the alternate interiors and the corresponding angles. Now, let's take a look at corresponding angles. Okay, and I'll do those in this yellow color right here. So the corresponding angles, what are the pairs of corresponding angles? Well, here I've listed them out for you. So we have 4 and 6. Angle 4 and angle 6 are both in the top right of their group of angles. If we're looking at this group of angles here and this group of angles here, 4 and 6 are both in the top right. And we can look at 5 and 1. 5 and 1 are in the top left. 2 and 7. 2 and 7 are the bottom left. And 3 and 8. 3 and 8 are in the bottom right. So those are our corresponding angles. Okay, and I've listed them over here. And then with our alternate interior angles, let me see if I can get rid of some of this stuff. Alternate interior angles. Let me see if I can get rid of this highlight. Ooh, that's working pretty good. I can get rid of this highlighting here. Oh, I didn't want to get rid of that. Let me undo that one real quick. Okay, see if I might have to write them. Oh, no, I did a good job. Let's see if I can get rid of that highlighting right there. Perfect. So the alternate interiors are going to be let's do highlighting in purple. Okay, the alternate interiors, that makes the Z. Remember the Z here? So we can say, I made the Z purple, so let's make it orange. Orange is a good color. 2 and 6 are alternate interior angles. And 3 and 5 are alternate interior angles. 2 and 6 and 3 and 5 are alternate interior angles. Remember, they alternate on opposite sides of the transversal, and then they're in the interior portions of the angles. Okay? All right. So the next thing we want to do is we want to come down and we want to talk about same side interior angles when lines are parallel. Okay, now here's the deal. What I want to talk about now is a very special case now if you look up here, I intentionally tried to show that N and M are not parallel. You can see they're very, try to intentionally show that this can happen. You can talk about these angles when they're not parallel. But if they happen to be parallel, then we get a lot of cool stuff that happens. And this is kind of the basic building blocks of a lot of things we're going to do in geometry. When we have two parallel lines and we have a transversal intersecting them. Now we could put three, remember it's two or more, but we're going to just right now just worry about the two parallel lines at a time. All right, now here's the first given, that these lines are parallel. How do we know they're parallel? It's got to be given. Okay, we have to be given that they're parallel. Now, one thing I want to show you is the parallel line symbol. Okay, the parallel line symbol, and I think we actually did talk about this on Thursday, but if not, we'll just kind of pick up where we left off. This two vertical lines right here running in the same direction, this is the parallel symbol. So even though N and M are running horizontal, we always just show it in the symbols, the symbolism here, we always just show the two parallel lines vertically. Okay, and so this is a given statement that N is parallel to M. Now, another way to show it, and again, I think I did show it to you guys, is actually putting interior arrows on the line, not on the ends. The ends mean it's a line and it doesn't ever end. Okay, it means it goes on forever. But when you put an interior arrow on it, one interior arrow here and one interior arrow here means these two lines are parallel. Okay, so this is a parallel statement and these are parallel statements. Either one of these are fine. Okay, normally we like this in our proof though. This is a statement a statement to use in a proof. And these are just visual representations. So this is just to kind of visually see it in the picture. But either they mean the same thing. Okay? Those are the same thing. All right. So where are we going here with this? We've talked about transversal. We've talked about all the different angles you get and kind of the names that kind of they go with and the pairs we can state. So now what we want to do is we want to get to this postulate. Now, it's a postulate, okay? But it still has to have a given. If a transversal intersects two parallel lines, and this has to be right here, it has to be given. Okay, this part right here, this has to be given. This is a given statement. Okay, now one other thing I want to add to this is it has to be on a plane. It has to be on a plane. Okay, it cannot be. And why are you saying, Mr. Roden, a plane is what I'm writing on a flat surface? Now, why would that be? Why would parallel lines? It has to be parallel because if you look at a sphere like the Earth is kind of spherical, not perfect, but let's say if we have the Earth here, longitude lines are actually parallel to each other. But since you're not on a plane, you're actually on a sphere. They're parallel to, but they actually intersect at the poles. So when you're on a sphere, parallel lines actually intersect. When you're on a flat surface, like I'm writing on right here, they never intersect. So on a flat surface, parallel lines don't intersect. But on a sphere, they do intersect. Okay, so yeah, so they'll come around here and they'll come down and intersect. So if you think of the longitude lines on a globe, they do intersect at the poles. And that's why we always want to say on a plane. So I'm not going to keep saying on a plane with all the stuff I'm doing today, but you have to, this is just something that we're going to assume, okay? We're going to assume this because there is geometry that's not planar and not on a plane, okay? It can be on a sphere, it can be on crazy shapes, 3D shapes, and then it completely changes your It completely changes your geometry. So the couple things, and I'm not going to keep repeating myself on this, but I just want you to remember it has to be on a plane, and then these lines have to be parallel. Okay, so those are the two big givens, on a plane and parallel. I'm not going to keep saying on a plane. We're just going to assume it. We're not going to do any geometry that's not on a plane for maybe a little at the very end, but we won't have to worry about parallel lines intersecting each other. All right. Okay, so now we have a postulate. If a transversal intersects two parallel lines, then the same side interior angles are supplementary. This is a postulate. There's no proof here. I cannot explain why this is true other than it's true. And that's geometry. That's what we do. We have to have some starting places here. So if I'm looking at a couple of lines, okay, we'll call this line G, and then, this is line H, and let's say we have just a transversal cutting them like that. We'll call it T. I always call it my transversal T. And so what we're saying is if we have an angle here, like angle 5, and we have angle 6 here, if these two lines are parallel, it's on a plane because my screen is a plane. I'm not writing it on a globe or something. So if we know they're parallel, either I can do it by pictures or I can say that G is parallel to H. Then I can now say that angle 5 is supplementary to angle 6. Likewise, if I had a couple other angles here, let's say I had angle 1 and 3 right here. And if G and H are parallel, then I can say that angle 1 is supplementary. I don't know why I put a big line on that P. That bugs me. Supplementary to angle 3. Okay? Now, what does it mean to be supplementary? By definition, and here's where we're going to go. When you got to go, there's two things. When you know they're supplementary, by definition, the measure of angle 5 is equal to the measure of angle 6. Remember, if we cut these out, we could take this angle, and if these were two different angles, we could put them on top of each other, and they'd be a straight line. In other words, and this one, sorry, my bad. They're not equal to each other. The measure of angle 5 plus the measure of angle 6. I was thinking they were congruent for a second. They're not always congruent, but they're supplementary. The measure of angle 5 plus the measure of angle 6 equals 180 degrees. Or if angle 1 is supplementary to angle 3, then we can say the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Okay, so remember, that's kind of when we're talking about supplementary, we're talking they make a 90-degree angle, a right angle, but most of the time we go straight to the definition after that when we add their measures, they're 180 degrees. So supplementary, add their measure, get 180 degrees. Okay? All right. It's a postulate, so there's no proof. No proof. It's just true. It's just an obviously true statement. Can't get around it. Okay. All right. Here we go. Now, the next thing we have our alternate interior angles. Let me go down here. Okay. So we have I kind of wrote this out a little neater. So we have our same side interior, supplementary. Okay. So now the next thing I want you to write down is the alternate interior angles theorem. The alternate interior angles theorem says this. Now, first of all, we're going to get right to our given, okay? Given P is parallel to Q and line T is a transversal on a plane. Prove angle 4 is congruent to angle 5. Okay, so what does the alternate interior angles theorem? Okay, alternate interior angles theorem says if all of this lines are parallel on a plane with a transversal, so if everything in green is true, if this stuff right here is true, then the alternate interior angles are congruent. In other words, if you look over at this picture here, if P and Q are parallel, then alternate interior angles are congruent. Always. Now, if you look at this picture right here, what are the alternate interior angles? Well, yeah, 4 and 5. 4 and 5 are alternate interior angles. Okay? All right. So we're going to prove here that 4 and 5 are going to be congruent to each other. Now, one thing I want to say is you're probably saying, well, Mr. Roden, why didn't you put like angle 2 right here? Why don't you say 3 and 2? Well, 3 and 2 are going to follow the same argument as 4 and 5. So at the end, all I'm going to do is prove that one pair are congruent. But if you wanted to prove the other pair, it would be the exact same argument, just with different angles. Okay, so I'm not going to prove both pairs. I'm going to prove one pair and just say you can use the same argument to prove the other pair. Okay, so if I prove one pair, the same argument will work with the second pair. All right, so let's go ahead and try this. All right, so what I'm going to do is I'm going to go through and put reasons here, statements, and then we'll talk about the reasons. Okay, so the first thing I need to say right off the bat is, let me go into the green here. I want to first of all say that P is parallel to Q. Okay, and why is that true? It's a given. Okay, it's a given. It's a given. I'm just giving that fact. All right, so the next thing I want to say is that the measure of angle 3 plus the measure of angle 5 equals 180. And before I even say that, I want to say this. I'll put it in here. So I actually want to say this. I'm going to say angle 3 is supplementary to angle 5. So I'm going to put that in my proof right now. Angle 3, and I'm going to abbreviate as sup. Angle 3 is sup. I like the saying that. Angle 5. Now, why is that true? Why is angle 3 supplementary to angle 5? Well, that is the same side interior angles theorem. Okay? The reason we can say that 3 and 5 are supplementary, and I can go ahead and put my parallel line symbol here because it's given. The reason I can say they're supplementary is because they are same side interior angles and the lines are parallel. Okay? Now, the next thing I can say is the measure of angle 3 plus the measure of angle 5 is equal to 180. Now, why can I say that? Why can I say the measure of angle 3 plus the measure of angle 5 is equal to 180? Well, I can say that because it's the definition of supplementary. Okay, awesome. When angles are supplementary, their measures always equal 180, and that's the reason, right? All right. I had to get rid of my picture there for a second because that's in my way. All right. So now, what's the next step? The next step is to say this: angle 3 and angle 4 are supplementary. Let me put that in there. So angle 3 and angle 4, I should put my little angle symbols in there, are supplementary. Now, why would those be supplementary? Well, you could think of it a couple ways. There's a couple ways to say it. You could say angle addition postulate, or you could say they're the linear pair. Linear pairs are always supplementary. Okay, they make a straight line. They're two angles that add up to straight line. They're a linear pair. Or you could say, I would say, angle addition postulate. Angle addition postulate is also a reason why the two angles add up to a straight line. Okay, all right, cool. So now, what can we say next? Well, the next thing we can say is that we can write this out, and we can say this. We can say that the measure of angle 3 plus the measure of angle 5 is equal to the measure of angle 3 I'm going to pause for a second here. All right, I'm back here. Okay, so let's see where I was out for a little while talking to my brother, so I've got to get back here. Okay, so angle 3 and angle 4 are supplementary. Okay, so they're supplementary because it's a linear pair or it's angle addition postulate. Okay, all right. So now what we can say is the measure of angle 3 plus the measure of angle 4 is equal to the measure of angle 3 plus the measure of angle 4. Now, why is that? So why can we say the measure of angle 3 plus the measure of angle 5 is equal to the measure of angle 3 plus the measure of angle 5? Excuse me, plus the measure of angle 4. Why can we say that? Well, yeah, because this is equal to 180 and this is equal to 180. It's just substitution. It's just substitution. Just substitution, okay? All right, so now where are we now? So now what we can do is, and this is a really common strategy, so just keep this in mind, this strategy that I'm doing, because we do it a lot. Notice what I have. I have the measure of angle 3 here, and I can subtract it off both sides using the subtraction property of equality, okay? The subtraction property of equality. So now I can say that the measure of angle 5 is equal to the measure of angle 4 because of the subtraction property of equality. And then after that, then I can say that measure of angle 5 right here. I can say that angle 5 is congruent to angle 4. Angle 5 is congruent to angle 4 because of the definition of congruence. And I'm done. So what have I just proven here? I've proven that if lines are parallel and a transversal crosses them, then the alternate interior angles are always congruent. They're always congruent. And if we put 3, 4, and 5 would be congruent. And then if I had like angle 2, we could use that same argument. We would just have different numbers in our measures and stuff to say 3 and 2 would be congruent. Okay? So from now on, if we see alternate interior angles, we can say they're congruent. And we've proved it. So we don't have to worry too much about the proof anymore. Okay? All right. So now let's talk about the corresponding angles theorem. All right, so first of all, what are corresponding angles? Remember from our lesson, corresponding angles are in the same position, their group of angles, and the top group of angles and the bottom group of angles, they're in the same position in their group of angles. So here, if you look at this kind of drawing right here, angle 3 and 2 are corresponding angles. Now, I'm only going to use this this proof for one pair, and then just like with the alternate interior angles, then the other pairs would follow the exact same argument. And so that's common. You just do it for one set of corresponding angles, and then you just say the other angles follow the exact same argument. Okay, so the first thing I want to do is I want to say that, and I'll go ahead and mark the picture right away. We're going to say that P parallels Q. So we want to get our given in there right away. So that's a given. Okay? All right. So the next thing I can say is that angle 1 is congruent to angle 2. Now, why can I say angle 1 is congruent to angle 2? Well, yeah, angle 1 is congruent to angle 2 because they're alternate interior angles. Alternate interior angles theorem. And I don't have to prove it because once we have a proof, we can just always use the theorem. All right, so now I know that 1 is congruent to 2. So let me write this out. So I also know that angle 1 is congruent to angle 3. Now, why do I know that angle 1 is congruent to angle? So let me say this. So why do I know that angle 1 is congruent to angle 3? Well, I know they're congruent because they're vertical angles. It's the vertical angles theorem. See how we're using stuff we've proved in the past? Vertical angles theorem. Again, we don't have to prove the theorem. It's already been proven. All right, so let me list out what we have here. So let's see here. So if I know that angle 2 is congruent to angle 1, and I also know that angle 1 is congruent to angle 2, what can I now say? Well, yeah, I can say, sorry, angle 3, my bad. So angle 1, let me say it one more time. Angle 1 is congruent, angle 2 is congruent to angle 1 because of the alternate interior angles theorem. Angle 1 is congruent to angle 3 because of the vertical angles theorem. So now what can I say? Well, yeah, angle 2 is congruent to angle 3. And why can I say that angle 2 is congruent to angle 3? It's the transitive property. Transitive property. And we've talked about the transitive property. If A equals B and B equals C, then we can skip the middleman. We can not worry about B and just go straight to A equals C. Same thing here. If 2 equals 2 congruent to 1 and 1 congruent to 3, we can just get rid of 1 and say 2 to 3. We can skip the middleman. And there we go. So now we can say that that's the easiest proof ever now. So now we can say that corresponding angles are congruent. And that would be true for all other angles. So if there's an angle 4 right here, then it would be congruent to this guy right here, 5. If there's an angle, let's see here, there's, what am I missing here? 6 right here, it would have to be congruent to angle 2, 3, 4, 5, 7 right here, right? 1, 2, and then 3 would be congruent. 3 and 2 are congruent. We could say that 7 and 6 are congruent, and we could say 1, maybe put an 8 here. 1 and 8 are congruent. So this argument will work for all of the pairs of corresponding angles. And we're done. So let's see here. So I have a last thing before you go today. Let's see if we can use our knowledge of angles to find degrees. So let's say I have this diagram here, and this is T, and then we'll just call this line A and line B, and then we'll just 1, 2, 3, 4, 5, 6, 7, 8. And let's say that I happen to know that I'm given that angle 1, I'm given that the measure of angle 1 equals 120 degrees. And I want to go through and I want to find all the other degree angles. And I have to have a reason for each one. It's not really a proof. I just need to have a good reason for it. Okay. So let's go through and see what we could do. So the first thing I could say that this one is 120 degrees. So this is a given. Now there's multiple ways to do this. So the way I'm doing it isn't exactly the way you would have to do it, but I'll just show you how I would fill it in. So do me a favor. Try to fill all these angles in and try to give a reason for each angle you get. Okay, so your job is to fill all the measures in and give a reason for each one. And I want you to pause the video now and go ahead and do that. Okay, so again, your reasons are going to be different than my reasons. So here goes. Or they may be the same. As long as you have a good reason behind it, we can figure it out. But in the end, we're going to have the same degrees for all of them. So the first thing I'm going to say is the measure of angle 4 is equal to the measure of angle 1, so it equals 120. And the reason why is vertical. It's vertical. So angle 4 is vertical to angle 1. Angle 4 is vertical to angle 1, and that's why. So angle 4 is vertical angle 1. So now I can say that this is 120 degrees. And then the next angle I see, here, right, how about this? So now I can say the measure of angle 5 is equal to 120 degrees. Now, why would the measure of angle 5 be 120 degrees? How do I know that? Well, it's an alternate interior angle to angle 4. It's alternate interior to 4. So we can see we got 4 here. So now we could say that this is 120 also. See that? Well, what could I say next? Well, yeah. How about angle 8? The measure of angle 8 equals 120 degrees. Now, why could I say that? The most obvious that I can see is that it's vertical to 5, or you could also say it's corresponding to 4. 8 is either vertical 5 or corresponding to 4, but it's still going to be 180 degrees. So why don't we haven't used corresponding yet, so it's, we'll say it's, go back to green here, it's corresponding to 4. Corresponding angles are always congruent. So now I could say that this is 120 degrees, right? All right, now I don't think I can do any more vertical. I don't think I can do any more corresponding. I don't think I can do any more alternate interiors. So I'm going to have to figure out something else. But how about this one right here? The measure of angle 7 equals 60 degrees. Now, how do I know that? Well, because there's a couple things. It's supplementary to 8. It's a linear pair. See that linear pair? Between 8 and 7 is a line, so that's a linear pair. So linear pairs are always supplementary to each other. So now I could say, because 120 plus 60 is 180, I could say that this is 60 degrees because they're a linear pair or they're supplementary to each other. Okay, now I'm in good shape. Why don't we do angle 3 now? Now I can say that angle 3, the measure of angle 3 equals 60 degrees. And why can I say that? Is because it's corresponding to angle 7. I mean, and there's lots of different reasons. It's almost like hard to pick the one you can use, right? There's so many good things we could pick. All right. And then how about angle 6? We haven't used alternate interiors yet. How about angle 6? Angle 6 is equal to 60 because it's an alternate interior to 3, or it's vertical to 7, or it's a linear pair, or it's supplementary to 8. There's tons of reasons now. Now it gets really easy. So now we could say that, I haven't used enough alternate interiors. We could say the measure of angle 6 is 60 because it's an alternate interior to 3. Again, you could have used a different one than me. Again, it's going to be different answers. Just depends on how you want to go. I'm going to say 60. And then, think about 2. You think about all the different ways you could get 2. 2 is equal to 60 degrees because it's vertical to 3. It's supplementary to 1. It's supplementary to 4. It's corresponding to 6. So take your pick there, right? 2 is pretty much anything. Vertical seems to be the most popular. So we could say that the measure of angle 3 is equal to is 60 degrees because it's vertical to 2, vertical to 3. All right, so that's 60 degrees. Now, one thing I do want to say that I forgot to do here that a good mathematician would be yelling at me now. I've got to say these lines are parallel. Before I can do all of this stuff, I would have to say those 2 lines are parallel. Now, vertical angles, it doesn't matter if the lines are parallel with vertical angles. It does matter with alternate interiors and corresponding. So we would never have been able to fill this all in if I did not know, and I should have told you that A is parallel to B. So this is something that has to be said first. This has to be said first before this whole thing can happen. And I should have said that, but hopefully you thought about that. Maybe you did. All right, guys. So now I think you're ready to finish up that homework assignment that's in the bucket. I'm hoping that you have enough information. Remember, each one of these problems are, they're not multiple choice. So you need to give me some good reasons why and explain your work in that homework assignment. I'm not going to give points for just one word answers or just answers. I want reasons. You can see geometry is definitely a reasoning deal. All right, guys. So I'm going to call it good, and I hope you guys have a great day, and we'll see you tomorrow. Bye.